Good morning, good afternoon, good evening, wherever you are. Thank you for joining us. We are super excited to talk about Spring and AI today. My name is Asir. At Microsoft, I'm on point for everything developers need to build, migrate, and scale Java apps on Azure. I'm also a Java dev. I started in 1995 with JDK1. Have been working with Java ever since, been at Microsoft for 19 years. And we have been working with a Spring team to enable AI for everyone. So with us, we have Mark. Mark from Spring team.
Yes, hi. Hello, everyone. Thanks for coming. Yeah, I've been working for a long time on the Spring team, going on 20 years, I guess. And currently, I'm the founder and the technical lead of the Spring AI project, which we'll be discussing today, in addition to Azure Spring Apps and all the AI goodness on Azure.
Okay, let's just drive straight in. You know, you can see these numbers, right? These numbers are shocking numbers here. At Microsoft, our mission is to empower every person and organization on the planet to achieve more. Now, you can see the rapid rise of advancements in AI and cloud computing. It makes access to technical skills an even more vital part of that mission for us. AI is here and its impact is real. Right? You can look at the study. The study is by IDC. It confirms that businesses are eager to adopt AI technology. With about 71% of the respondents, they say that they are currently using AI tools in their organization. And you can also see there's another 22% planning to do so in the next 12 months. However, even with this momentum and positive outlook for what AI can help them achieve, organizations are facing challenges when it comes to implementation. Now, this is where the developers, they're at the center, right? There's a shortage of skilled employees, and that's holding companies back from accelerating their AI-based innovations. With 52% of them reporting that there's a lack of skilled workers and needed to implement and scale AI initiatives across their company. So this is where the developers come into the center, and Java, Spring, they can all play a very, very important role right here. Now, we can confidently tell you that Java is one of the top languages used with Azure OpenAI. Julia Lewson, who's president of Microsoft Developer Division and GitHub, she spoke recently at JDConf about 3, 4 weeks ago, and that's where she highlighted that Java is among the top five in GitHub, and it is one of the most popular languages used with Azure OpenAI, where it is leading the charge in cutting edge AI development. And the Java usage on OpenAI is rapidly growing. So kudos to all the Java developers, Spring developers out there. Right? Let's take a look at some of the use cases driving these transformation. Right now, generative AI can transform business operations by enhancing productivity, automating processes, improving customer experiences, and also simplifying lots of content development. Right? Now, today, if you look at today, the challenges faced by business, they face major challenges like low productivity, need for automation, poor customer experiences, and a lot of time taken for creating content. These problems show that we need to find ways to work faster, automate tasks, improve our interactions with customers, and make content creation even easier. So, this is where the AI solutions come in. Generative AI provides powerful solutions to these issues. It changes how we search for information, how we write code, how we predict trends, and create reports, which saves time and boosts accuracy. Now, AI also helps automate tasks like processing documents, managing workflows, detecting fraud, optimizing supply chains, making operations quicker and more reliable. Additionally, AI enhances customer experiences by creating personalized content and improving service delivery, ensuring that interactions are so efficient and tailored to individual needs. For content creation, AI can generate marketing materials, design products, create digital art, allowing teams to focus more on strategic and creative work. So today, one of the things that we'll do throughout this exercise is we'll focus on some customer experiences by creating some personalized content and improving service delivery today. Now, across the board, when you look at all these use cases, AI can deliver some several strategic advantages. It helps businesses find new markets and revenue opportunities. It drives growth and innovation. We can also personalize AI-driven interactions that can build even more customer loyalty for your end customers and satisfaction, setting your business stand out and stand apart, right? And moreover, when you are doing automation, updating internal process, making operations, it will make me more efficient and more cost effective. Now, when we do all of these things, right, at the center, you'll be using your data. So that's a very important aspect that we'll be touching today. So when you place your data in the center and you work with your customers, or with your processes, whatever use case that is, right? It is critical for us to address the topic of data, emphasize that your data is your data. You can have full confidence when using Azure OpenAI service. When you use the service, your prompts, your completions, your embeddings, and your training data, they're all securely managed and protected. Specifically, data is not available to other customers and is not accessible to OpenAI. Additionally, your data is not used to improve Azure OpenAI models or any Microsoft or third-party products or services. Importantly, your data is not utilized for improving Azure OpenAI models unless you explicitly choose to fine-tune the models that you are working as training data, right? In such cases, your fine-tuned Azure OpenAI models are available exclusively for your use, that is your applications. The Azure OpenAI service is fully controlled by Microsoft, hosting the OpenAI models within Microsoft's Azure environment. This ensures that the service does not interact with any services operated by OpenAI, such as ChatGPT or the OpenAI API. This robust data privacy and security framework ensures that your data remains exclusively yours, providing you with the assurance needed to leverage Azure OpenAI service confidently. Now, if you dive into the Azure OpenAI service, it provides REST API access to OpenAI's powerful language models, including GPT-4, GPT-4 Turbo with Vision, GPT 3.5 Turbo, and embedding model series. In addition, the new GPT-4 and GPT 3.5 Turbo model series have now reached general availability. DALI is a series of models that can generate original images from natural language. Whisper, it's a series of models in preview that can transcribe and translate speech to text. We talked about data and keeping it central to your application, right? Now imagine OpenAI at the center of your data ecosystem, where developers and customers can bring in data from a variety of sources seamlessly. You can integrate data from local files, URLs, Cosmos DB, Azure Blob Storage, any SQL databases, Redis Cache, Elasticsearch databases, and many other data storages and databases, right? Now, this integration capability, it allows you to centralize your data, making it more accessible and easier to manage for intelligence. Once your data is integrated, you can infuse intelligence into your applications using the trained models from Azure OpenAI. If you're a Spring developer, there are many ways you can integrate the data in Spring, and you will see today how we are bringing them all together end to end. Whether you are working with structured data from SQL databases or unstructured data from local files and Azure AI Search, Azure OpenAI enables you to leverage AI models to drive insights and add advanced functionalities to your end applications. Right? This unified approach empowers you to create intelligent, data driven apps that can enhance productivity, automate processes, and deliver superior customer experiences. With that, this is where we want to bring into the Java part, right? You can build these intelligent apps using many different languages, right? Today, what we're going to do is we're going to focus on Java Spring, particularly how Spring AI can be used and how it unlocks the full power of the AI platform end to end. With that, I would like to bring Mark to the stage. He's going to introduce Spring AI and walk through many of the details there for us.
Yeah, thanks, Asir. So, as Asir mentioned, the great point in time that we're at now with AI technology is that it's accessible over common, easy to use RESTful APIs. That's a big distinction from before ChatGPT sort of made it very popular. And what that allows is for programming languages outside of the typical ecosystem from which AI developed, namely C and Python, to create AI applications. And you can bring all of your Java skills, all of your Spring skills, all of your software development skills to bear on this new type of application. So Spring AI is meant to fit into the family of Spring projects. There are many of them. And so many of the common idioms and design patterns that you see in other Spring projects are carried over into this project. And we provide these abstractions to help you get your job done. There are abstractions at different levels. Lower level abstractions, essentially, think of low level abstractions being like the JDBC API that Java provides in the SDK. We provide an equivalent portable chat completion client that serves as an analogous layer in the API to the fundamental JDBC one that provided portability across SQL databases. This is providing portability across invoking different AI models. And similarly, there's a bunch of components and technology that come along with this domain that probably are unfamiliar to many, but aren't too hard to wrap your head around. And one of those is called embedding client. So this is part of the technology stack that helps you bring your data to the model. And we'll discuss a little bit of that more later. Again, one component that is unique to this technology stack and bringing your own data is something called the vector database. Many companies make them, including Microsoft, and all of them have different query languages. So one thing that we did that's very common in the Spring portfolio is to provide a common abstraction, much like Spring Data Finder methods, let's say, that help you do queries in a portable way across different implementations of persistence technology. This lets you query the vector database using a SQL-like language, and it translates to the underlying vector database query language. So it makes things very portable and also makes things very easy to use, because even myself, as an experienced Java developer, find learning some of that syntax very difficult. We talk about generative AI and generative chat, right? And it usually focuses on text. I mean, that is primarily text in, text out is how we've been introduced to this technology because of the chat applications. But multimodality means you can also generate images, or you can also send images in with your request. For example, with GPT-4 and Vision, you could send a picture and ask the model to describe. So supporting all these different media types is another very important aspect that is a little maybe not on everyone's radar at the moment, but it's important, and that's an area of active development across all the models. There are other components as well. Function calling, we'll see a diagram in a moment. This is a way for the model to call your code based on what it reasons that it needs data for. So if you have a function in your code that gives temperature in different cities, and you ask a question that requires that input, the model is clever enough to call your function to get that information. And the key part of bringing your data to the model is a very lightweight ETL, extract, transform, load framework. And we'll be demoing that today on a bunch of PDF files. And last but not least, at the higher level, in terms of client interaction, we provide a chatbot component. This makes it very easy to have a one-liner, effectively, do query and answer type use case over your data. And similarly, a big concern for developing AI applications is, how do you know what the model is saying is correct? How do you know it's not hallucinating and just making things up? So evaluation is also something we'll demonstrate today. And it's important to keep in mind as you develop these applications. It's not sufficient just to see an answer come back and assume it's correct. You actually really have to verify it's correct, both at development time and also at runtime in production, to see how things are going, which is very distinct from other types of applications where if you just have integration tests or unit tests and it's green, everything's okay. Here you have much more moving parts, especially as these models that are hosted tend to get updated over time. I'm not able to, oh, there we go. I don't know what happened there. Yeah, sorry about that. So here's a very simple view of the application architecture. You have a user request coming into your app, usually over a web endpoint. And the keyword in the AI application space is prompt. The prompt consists of several things. Most importantly, it consists of your user request, but it also has other components. One other component it has is called a system message. This is basically giving the overall top-level guidance of how the model should answer and generate text. So you can do funny things like, say, always answer in the style of a pirate, right? And then it'll say, "Arg, mateys, here's your answer." And so this prompt gets sent over to the model, and it forms a completion or a generation. There are different terminologies. And then it responds, and you get your answer. But one important aspect of a lot of leading models is this component called function calling. It allows the AI model to reason over the question that's being asked and give it additional tools so that it knows how to retrieve data that it needs in order to solve the problem at hand. So function calling is this hook for its reasoning process to call back to functions that are in your app. I highlighted earlier, for example, suppose your app needed information on how to cancel an order. You could expose a cancel order function, and that would cancel an order in your inventory system. So these are some of the new moving pieces and new terms you might not be used to, and we'll see some of these in action. And highlighting again the portability that there is with Spring AI, you can use the same application code and swap out just the dependencies. And sometimes you have to change the prompt, but very little rewriting in terms of the structure of your application to support basically any AI model that's out there, whether it be from OpenAI or Azure OpenAI or from other vendors, right? Google's Gemini, Amazon's Bedrock, Hugging Face, local models such as Llama, and the list goes on because it's a very rapidly expanding field. So now we'll zoom in a little bit on how you get to use your data in an AI application. And so AI models, despite them being incredibly powerful, are limited. And they're limited in the sense that they're trained with public knowledge, and that public knowledge usually only goes up to a certain date. And because it's very expensive to train these models, you can't keep updating it effectively every day or every week. So you can go have a situation where the model you're using might be even up to a year out of date in terms of its public knowledge. And certainly, it's never trained about your private or corporate data that you have, in your own data centers. So those are the two kind of common limitations in terms of the data. And there are ways around this, right? One is to kind of do a more AI or machine learning centric approach, which is to actually update all the weights in the model based on a new data set, effectively fine tuning or slightly retraining the model. This is getting easier, but still quite a specialized task, right? That I would say Java developers, by and large, are not familiar with. This is definitely an area where specialization helps. However, there is a sneaky approach that is very effective. In a way, you can think of this like SQL injection, but for good. And what it is also kind of colloquially known as stuffing the prompt, where in addition to the data that comes in from the user, the question, you add information into the prompt to help the AI model answer. And this has become known as a technique called retrieval augmented generation, because you retrieve the data from some private corporate data store, you augment the prompt with that data, and then you send it over to the AI model to generate a response. And RAG is the three-letter acronym. So there are many strategies to doing this. When you get into it and try to when you try to optimize it, you can learn about these strategies. But we present, a very simple way for you to get started and then kind of grow into more sophisticated strategies. And that's what we'll be demoing today. So the use case we'll be highlighting today is a agent or employee assistance use case. We did this project as part of a pro bono work with a company called Carina. Carina, this was the company is located in Washington State, and it helps match healthcare workers with jobs, right? Either for the elderly or people who have disabilities. So think of it as, a matchmaking service, but in the domain of healthcare. And AI models, it's a relatively small company, even though some of this information is public. It's not trained on this, information. It doesn't know really what Carina is. If you ask it, the model, it thinks Carina is a constellation in the southern hemisphere. Clearly not a company that matches healthcare workers with jobs. So we need to bring data to the model in order for it to answer questions about this company. So what we'll be going through is an application that reads the frequently asked questions document from Carina and inserts it into this vector database, which is the main way you have to kind of chop up and process data. And the vector database we'll be using is one on Azure called AI Search. And this is a short-lived job. It means it starts and it ends, right? So it's kind of like a batch job. And there's new features in Azure Spring Apps to run short-lived applications, namely jobs. And so we'll be doing the loading step with this job functionality. And then the sort of long-lived app, right, is chatting with your docs, asking questions. And so we'll be searching the vector database called AI Search for these relevant documents, augmenting it, and then this app will be deployed also on Azure Spring Apps. So this is just to give you a little taste of what our ETL pipeline looks like. It's very simple. There's essentially relying on the Java util function packages. So we have a supplier. Supplier gets documents, mostly text, but it could have images too. But here we're just talking about text from some source. And we have a variety of implementations. So you can get sources from many places, such as SQL databases, files, and whatnot. And then we transform it, and there's definitely a specific way we need to transform these documents in these use cases, usually by splitting it up into small pieces. So one PDF gets chopped up into many small paragraphs, if you like. And then we have to write it, right? And so we have a consumer that writes it typically into a vector store, and you'll see we support lots of vector stores. Sorry. So the reason we have some of this transformation, and you can't just send your whole PDF or all your data, is there's another limitation of the model is a concept called context window. So this is another sort of new piece of the puzzle that you need to learn to make AI applications. Again, it's not too hard. Just think of it as the RAM, right, of your app. And so this is starting off in kilobytes, right? So a window of 16K is kind of what models started at. Now it's kind of gotten a factor of 10 higher. You can get 128K. And you can think basically the context window is measured in a concept called tokens. Tokens are about 3/4 of a word. Even if you want to ignore that exact, relationship, the idea is it's limited. So you have to not just pass it a PDF file, right, the whole thing, and say figure it out, because you could easily, go over the limit of 16K. You have to first split it up into small chunks, and once it's split up into small chunks, when you get your question, you have to find which chunks are relevant, right, for that question, and then augment those chunks. So that's what the vector database is commonly used for. And the technical details of how you do this is creating something called embeddings. We don't need to get into too much of the details here, but machines like to deal with numbers, right? They don't like to deal with words. And you convert words into vectors. And if you think of it simply in 2 dimensions, and you picture a vector pointing in space, it can say, given your question, it's pointing in space some direction, it finds other similar words and other similar documents that are similar to it, that point close to it. And that's why there's the word vector there. And that technique is called embedding. It's a whole separate technique. We hide a lot of that, but if you really want to dig into the details, you can go underneath and see how it all works. But it's pretty straightforward. But again, trying to go over some of the new terminology for Java developers to get familiar with this space. Just like in enterprise application integration, there are techniques and patterns, or microservices, there are various techniques and patterns. A similar thing here. There's a bunch of common techniques and patterns for creating AI applications. So this shows an example. You might want to create a chat bot on the Winter Olympics from 2022. And at the time I made this slide, OpenAI's model hadn't yet been updated to include 2022. And if you look at the size of all the Winter Olympics articles on Wikipedia, it's way bigger than 16K. It's even way bigger than 128K. So even the current models that OpenAI offers wouldn't have enough size in their working memory, their RAM/context window, in order to keep all of that data in mind while formulating an answer. So we split it up. There's a little algorithm to doing that. Again, there are heuristics here that, once you really start getting into the details and trying to make it more and more accurate, it's important to understand how you split, but you can get pretty far with pretty simple techniques. And for each little split document, maybe just think of them as a paragraph or two, we created an embedding, which is this mathematical representation of those words, and we store it in this vector database. So now the architecture that we have for retrieval augmented generation is you still have the user request coming in. That's used to help create a prompt. But now, based on that user request, we retrieve data, right? We retrieve data from this vector database. And this can come from many vector databases using the same API. So if you're working locally and you're using Redis, then it's very easy for you to switch dependencies, keep the same API, and point it to Azure AI Search. So once you retrieve that, it gets added to the prompt, sent over, you get a completion, and you get the response based on that. And here I'm just highlighting there is a context window that you can't go over. And the context window, interestingly, also includes the output. So you have to kind of figure out what type of question you might be answering and weight it appropriately. So If you're asking it to generate a lot of content, like please generate a next great American novel, you want to have a lot of room in this context window for the output. However, usually the nature of retrieval augmented generation is kind of like present the question and get an answer, and the answer is usually pretty brief. So kind of want to load up more information into the content retrieval aspect, so it has as much information as possible to give you a correct answer. So with that as the setup, we'll walk through the code now and how to do these two steps. First, the loading of the data into the vector database, and then doing the query. And we'll show some evaluation. We'll show how you deal with updates of the documents and how you can manage that. So here I have a loading application. Let's look at the POM. There's not a lot going on here, but we'll walk through it. So essentially, this is where all the good stuff starts. We're using a starter, right, for Azure's OpenAI. And this allows us to have connectivity to embeddings and connectivity to the AI model. We'd like to read from a PDF file. So one of the dependencies we have in this ETL framework is to read from a PDF. So that's what we import here. And we'd like to load this vector database using the one offered by Azure. And if we look at the configuration, what we do here is essentially add a bean into our configuration for the vector store. And this is what's important here, and I think what's often not shown, is that when you add this information, essentially that gets two-dimensional, n-dimensional vectors, there's metadata associated with it, right? How do you know, based on this n-dimensional vector, what it means, right? What data it represents. And this is where you can add fields such as file name or version, and those will be stored alongside each row effectively in the database, so that you can have multiple files, all stored inside the same instance of this vector database. So that's what we're setting up here, is this metadata. And later when we do the query, we're going to reference some of this metadata. The application is just a plain thing. Maybe it's now a good time to show the config. I don't have the API keys here, but basically this is the connectivity to the model. In this case, it's GPT 3.5 Turbo 16K. And you can see this 16K, this is what I was referring to before as the context window, or the so-called RAM, let's say, of the model. And it's in the name because it's very important to know. And this is the configuration for the vector store. Again, pretty easy. We look at the job. What we're going to do is load two files, and they differ only in a small way. I'll show you here. Let's drag it over. So this is this document about Medicaid fact. What is Karina? Who's who? How does it work? It's a fairly straightforward, simple document. Nothing too crazy in terms of formatting. And the only thing I changed between the two is that it was founded in 2016, and just to have a difference in the doc, I updated it myself and changed it to be founded in 2017. So otherwise, these two documents are the same. So you can use typical Spring idioms, value annotation, resource abstraction, and get reference to these two files. We've have this vector store, which we created before in the configuration. And this is a command line running app, right? So it basically runs and exits. Sorry, that's what that does. And here's the ETL part, right? This code here, right, is how we read the document. And there's a little bit of formatting here, so you don't get footers and headers included. PDFs are highly unstructured, so there is a little bit of playing you have to do to get this to work correctly. And this is the splitter, right? And so this is what I was talking about, going from big document to chunking it up. And this splits it on a certain size token. I think the default is 2K of tokens, but it's customizable. So we extract the text, we do a transformation, and now we're going to do a load. But before we do that, I wanted to make sure to add a version number associated with this as part of the metadata. So when we call it, we have version 1 and version 2. And last but not least, we load this. So one way we can run this, you can build this app, which I already did, but we'll run this, by using the Azure Spring Apps job support. Let me just bring up the, here is this. The portal. So you can see there are jobs here, and I've run these before. I just don't want to do it the first time in front of you all. But essentially, we're going to run a job, and what we like to do is populate the vector store that's under AI search. Provision this already, but there are no so-called indices created, so this is kind of like your space within that service, and right now there's nothing there. So we're going to run this app, and it's going to upload this short-lived job to Azure Spring's app, and then you can see that this is a preview feature that will be GA'd at some later date. So just to make clear, there's a distinction of two application types in Azure Spring Apps. One is the one that you might already be familiar with, that's existed since the beginning of Azure Spring Apps. And these are typically long-lived apps, typically web applications, and if the application dies, it gets restarted. What we have here with jobs is it's a short-lived app, right? It's meant to terminate. And so the infrastructure knows that it's a short-lived job, and when it exits, it keeps track of its status. Did it have a good exit code? Did it have a bad exit code? But it doesn't try to restart it again. All right, so building it. Okay. So once it's done doing that, then we'll run it. I thought I had set this up so it wouldn't waste our time. I must have touched a file or something inadvertently. Okay. So it's there now, and the reason you have a start command is because you can start multiple instances with different command line parameters. Here, we're not using any command line parameters. We're just loading. So let's start this job. And then we can see it executing. And with this command here, AZ Spring Job execution list. So you see those are the ones I practiced on earlier in the day. And we'll just keep checking it until it finishes. It doesn't take very long to load this, as you might imagine. So it's done. So now if we refresh here and go into this view, do a search, see we have a bunch of data here. And this is the vector, right, that we were talking about. It's thousands of dimensions. You can see it's very big. But at the end of it somewhere, there we go. I want to get to that part. You can see this is where the metadata is, right? And so this is important. You have the file name, the page number it came from, and the version, right? So we'll be using that later. So we've loaded the data now. Now we'd like to query it. So I have a separate application here. This is chat application. So again, similar configuration. We need to read now from the same index, and we're using the same model. This time not for embedding, but for completions. And we can walk through the application configuration. And this is the vector store as was defined before, same thing. However, now we're using a very high-level abstraction that Spring offers. This is new. It's something that's still a bit of work in progress, but I thought it was worthwhile to show versus the lower-level abstractions because it makes this common use case really so simple. So we're going to create a chatbot. And in particular, we're going to say, we only are interested in version 1. Remember, this is the one that has the year 2006 as the date that the company Carina was founded. And we create a builder. And we say, well, I'd like to use a vector store. And you hand it the vector store. You hand it this search request, which limits the scope of what you retrieve to be only version 1 of the PDF. And then this is setting up the prompt in the appropriate way so that it combines that data. So it, trying to follow this RAG terminology. So you have with retriever, that's the R in RAG, augmenter, right? So we're taking the question that came from the user and we're augmenting it with context, right? And the context is what's returned from this search result. The application is just this standard boilerplate. And here is the very small controller. So that's where the request mapping is, the default question, what is the purpose of Carina? And here's where we create a prompt. The prompt represents the user input, but that's encapsulated by a class called user message. You could have something called system message here as well. That's where you could stylize in a way or give more context to the overall way that the model should answer. Like jokingly, I mentioned earlier, you can have it respond in the voice of a pirate or something else. And all you do is call it, and you get the response back and return it as a map. So you can see, very, very simple. Not a lot of moving parts. We look at the dependencies here. We have, again, the boot starter for connecting to Azure, and we have the Azure vector store. And that's about it. And what I'll show here is how do you know that the answer you get to a question is correct, right? So you can write JUnit tests, in particular in the real world, probably parameterized JUnit tests. But what we're doing here is saying, what is the purpose of Carina? And we call the chatbot just like we did in the controller. But now we have something called a relevancy evaluator. We won't get into the details here, but effectively it's asking the model based on the answer and the question, did it make sense, right? Kind of something as high level as that, believe it or not. So there's a lot of interesting dog fooding that goes on in how you use AI model for the generation, but you can also use the AI model for the evaluation. So as you're developing your app, you can create appropriate series of questions and then know that they all pass. And that's kind of the way you do what people at Llama Index, I think, a company, have coined evaluation-driven development. So I'll run this here just for fun, and it'll pass. Although it looks kind of like black box to you, just know that this is the handle that you get to see if things are working well or not. So that passed. So you say, okay, good. I think I have a fairly decent chat bot. So now I'm going to deploy this, right? This will take just a moment. I'll check the comments here, see if there's anything to talk about. No comment yet. Probably should have walked through the evaluation while we waited for this to upload.
Perhaps you can show the pom.xml for this app.
Yeah, I did already, but I'll show it again.
Yeah, that way.
You have this dependency, right? So
Hmm.
not much, use your
Yeah,
for embedding and model completion, and this is for the vector store.
this all makes it super simple for our developers, right? So that they can quickly jump in and focus on the intelligence part.
Yes. All right, so it's been successfully deployed to Azure Spring Apps. Is it remembered? Whoops. So, yeah, what is the purpose of Karina? Right? Provide online platform to connect with care providers and so on. And then you could say, when was it founded? And so if we go back to the version 1 of this doc, see, it was founded in 2016. That's what we expect to hear. Yep. So now, if we go back to the app and we change this to 2, and we build it, and we'll redeploy it again. Trying to think of something fun to do. Actually, it looks like my slides might be a little. Oh no, that's okay. So any guess? Yeah. So we're planning July. So we'll have a milestone 1 release this week with this chatbot functionality. That's a question that's on the chat over here. So soon. I started this project last summer. I guess my lesson learned is you think it'll take a short time, but basically going from 0 to GA always seems to take about a year. All right, it's flipping around. And so what we expect to see, just as a reminder, is I changed the version 2 of this document to be 2017. All right, so now there's some things. Okay, succeeded. So now if I ask when it was founded, 2017. And if you ask it the other question, you will get the same answer, right? Easy to use online platform. Great. So let me start. Oops. I'm going to start from the beginning.
So this job can be continuously running and keep the app intelligent all the time, right? So it doesn't have to be stale at all.
Correct. Yeah, that's the important thing to realize, that there are sort of two distinct things. There's the loading, right, and then the retrieval. And data in the enterprise always changes. There's always new versions. So it's important to see how you can get a handle on that real world case, right, of constantly keeping up to date with whatever the latest data of your enterprise is. So yeah, there was a question on the roadmap, and yeah, so these are some of the high level things. You can go on GitHub to see more details. There are a lot of models. We already support quite a lot, but it's amazing how many there are. Even within sort of mainstream, let's call it foundational models, There's quite a lot, easily like a good dozen from each vendor, right? So you end up having support hundreds of models effectively, all with one portable API. So it's a fair amount of work, but I think we've kind of cracked the nut on that one. And we still, are sort of relentlessly focused on this portability model. And so it doesn't sound very exciting, but it does take time to get correct. You don't want to create an abstraction that doesn't let you get down when you need to the specific things that aren't portable in a model, right? And so that's the hard design aspect of it, right? And yeah, I'd say that's about it. I can tell we're running close to the end now. I think I'll just hand it back to Asir. Thanks.
Okay. Thank you, Mark. Let's switch to my screen here. As you can see, both the Java Spring team in Microsoft Azure, as well as the Spring team in Broadcom, we've been working together to constantly innovate to get where we are. Our goal is to make it as simple as possible, just like the way Mark showed, so that the amount of new things that you have to learn are very small, and you can continue to use concepts like the function calling, the Spring data, many of those pieces that come with integrations in the Spring that you can reuse them, right? This way, you can quickly adapt, learn. At the same time, the organizations that are looking for skills can find you to make sure that they can also progress their use cases. Now, the AI learning journey is unique to each of us. You can see it in the diagram on the screen here. It's not linear. There's no predefined paths or mandatory stages. It's like a framework and a tool to help you and your teams and your broader teams to discover the right training resources to gain the skill you need when you need them. So you can think of these four phases. You try to understand, you prepare, you use AI, and then you build solutions, right? Now, understanding AI means becoming fluent, getting to know the basics of the AI concepts. Mark and I introduced many of the concepts here. These are simple terms. It includes what's there, what are the services, what are the technologies, how you can take advantage of them, and how Microsoft AI and Spring AI can help your team members. Right? It also includes skills in responsible AI, so including the principles and the best practices that ensure that AI work is accountable, inclusive, reliable, safe, fair, transparent, secure, and it respects all kinds of privacy parts as well. Now, preparing AI is about acquiring the knowledge to successfully get your teams, your organization ready to later use co-pilots and build these AI apps that we showed you today. In other words, as an individual or organization, you need certain skills now to establish the infra your organization must have to enable and use the AI solution successfully. Now, using AI is about understanding co-pilots, getting the skills to write good prompts. You can try it in ChatGPT or in AI Studio, Azure AI Studio, and get the best out of the generative AI. So you can use co-pilots effectively and build apps as well. So when it comes to building solutions, it's all about the transformational experiences you can bring into your apps, Spring apps, Java apps, and services using Azure AI and other parts of the AI platform in Azure, and including the Spring AI that Mark introduced so that you can unlock the thing end to end. Now, this stage, it's all about getting the skills in a way and getting together. So the learning journey is unique to each of us. It's not linear. They're not predefined paths, or there's no mandatory stages. It's a framework to help you and your team discover these training resources. So what we'll do is we'll show you these resources. They're all here. The slide deck will be available to you, and those links are active. So you can use these links. Now, AI may impact multiple roles across your organizations, from business and technical leaders to business users and technical roles, right? So if you're looking for a more focused learning by role, what we have done is we have curated and organized the training resources to help each role navigate through each of these stages in their journey, with emphasis on what is more relevant to that particular role. So you can use this to learn. The other thing that we want to leave with you is whatever you learn today, you can start today, right? You can use Spring AI to chat with Azure OpenAI models using your data. And the apps that we used in the presentation, the links are right there. You can actually get them. We also have a end-to-end workshop that we worked with Mark. He has worked in a way that you gradually go from step by step. It is available on Azure GitHub. You can use that to learn. And if you're getting started to build, there's also a quick start. The link is right there. That was built by Greg Meyer from Spring Team. You can use that to get started. And if you want to link to the Spring AI framework that Mark was playing today, the link is right there. Now, if you want to see a full end-to-end, full stack that uses your the AI parts, we have the fitness store, and you can see that aka.ms fitness store. And when you're deploying, the easy way to deploy in Azure is the Azure Spring Apps. To launch your first app, the link is Start ASA, right? This way you can get started today. So, Mark and I would like to thank everybody. Thanks for joining us, and thanks for taking the opportunity to learn so that your organizations can leverage your skill set and build amazing, amazing apps. And please let us know how you are building these amazing apps. So, we do have some time, so we can use to answer any questions that show up on the comments window.
Oh, I think we lost us here. All right. Well,
Sorry, looks like I got cut.
there's one question, something about student access or something like that. I'm trying to find it.
What's student access? Can you
I
please
don't know.
specify if they
I'm
have?
trying to find the. Oh, do these apps have a student version? No. So these apps are on GitHub, freely accessible.
Yeah, they
So
are accessible to
everyone can
anybody.
get them.
Yeah,
Student and professor can get them.
correct. Anybody can get them. Yes.
Oh, I don't see any other questions. I guess you could always leave an issue on or a discussion on a project page on GitHub.
Yeah, you can leave it on project page and all the repos that we showed. You can open issues and interact with the authors of the repo. That way, you get the best experience.